Okay, it's been a couple of days, so I have mentally recovered from that last question on paper one, which is, again, my fault because I was being silly. So I think I'm ready to do paper two. I don't like paper twos just because I don't like using a calculator. There's like, I don't think the work and the answers and the way that you do the math is as elegant as it can be in paper one. But nevertheless, let's just get this over with. This looks like a standard cosine law question. What do we want to do? Find BC? Yeah, okay. So, standard cosine law question. X squared is equal to the other two sides squared and added together minus 2 times the two sides times cosine 116. Okay. Put this into a calculator. Make sure I'm in degree mode. Okay. 12 squared plus 7 squared minus 2 times 12 times 7 times cosine 116. Okay, that's x squared, square root it. 16.3. Paper 2, 3 significant figures. Okay, no units? Yeah. Find ACB, angle ACB. So follow the letters ACB, this angle right here. Okay, you can use cosine law again because if you have three sides, the length of three sides, you can find any of the angles. We also now have, I call this like a pair. You have an angle and its opposite side, and sine law lets you complete another pair. So I have this side, I can complete its pair and find the opposite angle. So that's a sine law question. And then like there's ambiguity and stuff, but because we have all three sides, that means that the angles, and this one's like 116, I don't think there's any ambiguity. Plus, if you can use cosine law, then that doesn't have any ambiguity, so there's no reason to be worried about ambiguity if we were to use a sine law question, which I will. So what is this? Sine of the angle over 7 is equal to sine of 116 over 16.3. Okay, calculator. Oh, I probably shouldn't have cleared that. Oh well. Sine 116 divided by 16.3 times 7. Okay, so this is sine of your angle. Take the arc sine of this. (22.7 degrees). Sure, standard SL level question. Usually the first couple questions are SL level, like first 5, and then they transition into HL level. Question 2, consider this function a factor of this polynomial. Oh, okay, I said that too soon. This is an HL level question. That's kind of unusual. It's a factor remainder theorem question. So if you divide a polynomial by a binomial in the form of x minus a, then the remainder theorem says that if you plug in the value of a into your function, so like this sentence right here, if I plug in 3 into x and I calculate it, the function will give me the remainder of -2 when I calculate it out. So 2 times 3 to the power of 4 minus 6 times 3 to the power of 3 plus 9p, 3 squared is 9, plus 3q minus 2 is equal to -2. So that's a remainder theorem. we combine this with the factor theorem, which says that if you have something that's a factor, then you don't have a remainder, which is kind of obvious statement. And then if we combine it with the remainder theorem, then that means that if I substitute in 1, so I get 2 minus 6 plus p plus q minus 2, I should not get a remainder. So it's 0. Then I have a system of equations. We're going to solve for p and q. Let's clean them up a little bit. So in the first equation here, this cancels to make 0 on the right side. And then what is this? Okay, I'm just going to calculate this out. 2 times 81 minus 6 times 27. Oh, that's nice. 0? Oh yeah, that makes sense. If you pull out a 3, then that's 6 times 3 to the power of 3, so then these would cancel. Cool. So our first equation is 9p plus 3q equals 0. Our second equation, these cancel, and then I'll move the 6 over. 6. Okay, and then this is fairly simple to do an elimination. So I'm going to multiply everything by 3, subtract the second equation from the first. So I get what? 6p is equal to negative 18. That means that p is negative 3, which means that q is positive 3. Positive 3? No. So p plus q is equal to 6, so q is 9. Yeah, pretty standard. Okay, question 3. Supermarket analyzes shopping habits of customer. The number of times X each customer visits a supermarket in a given week is this probability distribution. Okay. Sure. Why did they put 0 here? I guess if they didn't include it, then maybe like some people would be worried. Well, what about the people that go more than 5 times a week? Whatever. Let's see, find the value of A. So A is down here in our probability row. We know, right, if we sum these, it needs to equal to 1. So 1.5 plus 2 plus 1 is 4.5. 4.5a is equal to 1, subtract off the other probabilities. So A is going to be 1 minus 0.281 minus 0.026. Divide this by 4.5. So 0.154. Okay. Next up, write down the mode of X. So the mode of a random variable is the event that is most likely to appear or would appear the most. In other words, that's the one with the highest probability. If A is 0.154, then I believe 2, X being 2, is the mode. Because then 2A would be like more than 0.3, so then it's the highest value here. Okay, easy peasy. Next up, find the mean. So the mean, or the average, is the expected value. To find the expected value, you multiply each value of the random variable with its probability, and then you sum them all up. Okay, so let's do that. So we have 1 times 1.5 times 0.154 plus 2 times 2 times 0.154 plus 3 times 0.2181 plus 4 times 0.154 plus 5 times 0.026, and then we get 2.44. Okay, next up we want to calculate or find the variance. So the variance, it has a formula. In the HL section, right here. So the variance is the expected value of x squared minus the squared of the expected value. So we have this part right here already, the expected value. We will need to calculate this thing, expected value of x squared. And then I had a kid ask me, like, what does this mean? And why do we do it? Because what expected value of x squared is you square the x values and then you multiply it with the probability as it is, and then you sum them all up. And then they had a hard time understanding the significance or the meaning behind that, or why you would do that. And to be honest, okay, I don't have a statistics degree, so my statistics is like meh. I could not tell them the answer. I think this is like something to do with like moments, like it's a statistics term. Like this is the second moment, and then expected value is the first moment. But essentially, should I yap about this? Okay, I'm gonna yap about this. I did want this to stay under 2 hours. I don't think that's happening, but it's good if for you guys to have a good understanding of statistics anyways. Not a lot of people do, but okay. Let's say that you're measuring the height of people. So you have like 3 people, 4 people, 5 people, doesn't really matter. And then you can calculate their average. So their average, let's say, is like here. So this is their average height. And then once you calculate their average, in statistics, a lot of things you would like to do is then calculate, okay, how far apart are each of these people from the average? So this person here is like, 3 centimeters taller. This person is like 2 centimeters shorter. This person is the average height. Maybe this person is like, I don't know, 2. And then let's say this person is -4. Not to scale. Okay, so then these are called residuals, right? It's just how much more or less each individual person is compared to their average. Now, what you would do is you can say, okay, like what's the average distance away from the center, or the average, the mean itself, right? What's the average distance? What's the average of whatever? So if you were to do that and just calculate a straight up mean, some numbers are negative, some numbers are positive. So when you sum these up and then divide by 1, 2, 3, 4, 5 numbers, you will not get a proper representation of what an average distance is away from the mean. So what they would do, or what they have decided to do, is they square the number. This is one reason why you would square the number. You square the number to get rid of the negatives. So you take the residuals and then you square them. So you get 9, you get 4, you get 0, you get 4, and then you get 16, right? You square the negatives, they also become positive. And then what this also does is this puts more emphasis on numbers that are further away from the average. So the people that are taller have a greater impact on the distance away from the average. So when you square their residual, it will be a much larger number, and they have a greater impact on the average distance away from the average. Sorry, mean and average, you know, and then so then that's why you square them. You square them, then you take the average of this number, the mean of this. This thing is the variance. Then, because you squared the residuals, this is just the average square distance away from the center. Then you have your standard deviation, STD. This is the square root, because if you talk about units, variance in this question would be centimeters squared, because all of these are like centimeters squared. So the standard deviation, we would square root the variance to get a more understandable statistic measurement, right? This would be in centimeters. So that's what variance is. So how does that play into here? Find the variance of a random variable. Basically, like you do all of this, right? Okay, I'm gonna do this very quickly because I'm spending way too much time on this. So variance is you take the residual, you square them, you average them. So in terms of, let's say you have a random variable x, right? And then this has like different outcomes, x1 all the way through xn. And then these have their own probabilities, p1 all the way to pn. Then the formula for variance, first off, we need to calculate their average. This. We know that that's the expected value. So this is literally just the sum of x times p from, 1 to n. So your variance, right, is each individual x subtract the average. So this is your residual, right? Let me color code this. So this is your average, right? This is your residual, right? That's this. You square them to get rid of the negatives. You sum them, and then you divide by how many numbers you have, which should be n. Okay, and then if you like manipulate this formula, and then I'm trying to see how this works. And then I might just be wasting time. So if you've been following me so far, I might just be like doing some silliness right now. I don't know what I'm doing. I thought I was cooking something. Okay, I'm expanding the polynomial. I'm splitting the summation. I don't think I need to divide by n. Because this is talking about probability. Maybe it just looks like this. Okay. So I'm just manipulating this. I might be going nowhere with this, to be honest. You know, I don't waste any more time. I'm sorry. But basically, you take this formula, right, which is based off of this theory of taking averages and stuff, and if you manipulate it, you end up with this expression for variance. I thought I could just do this without knowing enough, right? But I don't know. Like, you manipulate it, and then you should get this summation, which is what I was trying to show. You end up with the summation of x times p squared, and then this one, you have a summation of x squared p. And I was kind of getting there somewhere, but point is, like this, I don't think it doesn't have a meaning per se, at least not that I know of. It's just if you follow the formula and then you manipulate the summation, you end up with this expression, which is equivalent of finding the expected value of x squared. I don't know, someone that knows statistics better than me could probably say it. I never took a statistics class in my life. I wasted way too much time. Okay, let's just get this over with. Okay, 1.5 times 0.154 plus 4 times 2 times 0.154 plus 9 times 0.281 plus 16 times 0.154 plus 25 times 0.026. Okay, so this is my EX squared, 7.11. Okay, so then your variance is 7.11 minus 2.44 squared. Okay, 115. Okay, next up. Customer wants to know something, blah blah blah. They survey the first 50 customers. Which of the following best describes the sampling method? I've never seen them ask about sampling method. But you're asking for the first 50 customers, so that's literally you're doing a convenience sample. It's the easiest thing for you. Simple random means you're randomly selecting customers. Systematic means that you have a system you're following an interval, like every 5th customer that enters the store you ask. Quota, I don't know what quota is. And then stratified is like you split them into natural groupings, and then you select from each group a little bit from each group. Natural groupings, as in things that exist within the structure of the people you're sampling. So if you were to you're in a school and you want to find out the opinion of something, a very natural grouping would be to ask a little bit of people from each year or each grade, because that's a natural grouping. If you're in a city, maybe it's like different neighborhoods, because people in a neighborhood probably have a similar opinion on certain things. So that's stratified. I don't know what quota is. You guys can just Google that. Okay, this looks like a arc length, arc sector area type question. So, okay, before I do this, I'm gonna write down the formulas. I think that's r squared. Okay. So what do we got? We got the angle of area of this triangle is 26. AOB is 2.51. Yeah. Find the arc length of ACB. Okay, arc length of ACB. Follow the letters A, C, B. Okay, do we know the radius? We do not, so that's something that we will need to find. Okay, so we need to find the radius. We're going to use the fact that we know the area of the triangle is 26. And we know that the angle is 2.51. So from here, this means that your radius is 2 times 26 divided by theta, rooted. So 4.55 centimeters. Okay, and then we want to find this arc length. So then we need to find out this angle here. And then that's easy because this is the other part of the circle. So this is 2 pi minus 2.51. And then this goes into here. And then that one goes into here. Okay. So 4.55 times 2 pi minus 2.51. 17.2. Okay, easy peasy. Consider this function. Find an expression for f prime in terms of a. Okay. You know. Okay, we gotta use quotient rule, I guess. Ugh. I never remember quotient rule. I think the derivative of the top one divided by first. Yeah, derivative of the top one times the bottom one first. Subtract the other way around. I always forget the order. Okay, so take the derivative of the top. We're gonna, so that's 3, 2x plus a 2 chain rule, so this is 6 times x plus 5 squared minus 2 times x plus 5, that's the derivative of the bottom, times the top, over the bottom squared. So this is now 4. Okay. I guess you should simplify. Just a tiny bit. Because, yeah. This 3. Sure. Something like this. I wouldn't expand it out. That's a waste of time. B. When x is 1, the tangent to the graph of f makes an angle of 70 degrees to the horizontal. Find the smallest value of a. Okay, well first, if I know x is 1, I'm going to find... I'm going to find this first. So 6 times 2 plus a squared plus 1 times 1 plus 5, which is 6. Minus 2 plus a cubed. And then this is 6 to the power 3. Can I make this look any better? I want to make this look better. I don't think I can make it look that much better though. This looks awful. I don't know if making it look better is gonna help. But you never know. What's 6 to the power 3? Like 216 or something? Okay, so this is your gradient or your slope. This, if you had a line with this slope, it's going to make an angle of 70 degrees to the horizontal. So let's say you got your function, right? It has a tangent. This is where, when x is 1. And they're saying that this angle is 70 degrees. Okay. So in case you you need to be able to connect a gradient with the angle, and this is something that we can do. Essentially, this is your rise, and then this is the run of your slope or your gradient. Oh, I can't change colors right now? Okay. And then how are these connected with the angle? Well, that's with trigonometry. We know that the arctan, or well, let's keep it simple. We know that tan of the opposite side of a right triangle divided by the adjacent side, essentially the rise and the run, should, oops, I have this backwards. Tan of the angle is equal to the gradient, which means, right, that tan 70 degrees is equal to this stuff here. And then this is a very ugly equation. Just solve it using an equation solver. And we want to find the smallest value of A. This is going to have like 3 answers, 2 answers of A. 2 distinct answers of A, and then we can just pick the smallest one. Okay, so there was really no point in me simplifying it because it's a equation solver question. So solve, I'm gonna use Wolfram Alpha. You have your graphing calculator, GDC. And then, I don't know, do I trust my simplified version? I do not. I'll probably just do this one. Okay, I'm gonna type it off screen so that I can see it. Okay. Okay, so here it is, right? Equation solve. Choose the smallest value. Is A. A has to be a positive number though. So that's 2.72, I guess. It might be wrong. If it's wrong, then it's because, I don't know, I typed this in wrong or something. But that's the theory, or the how you would approach it. How's my time? 40 minutes. I'm on question 8 or 6. Each question is an average of like 6 marks. 6 times 6 is 36. So I'm like 4 minutes behind. Probably because I tried to explain that variance thing. Okay, let's see. ABC vectors, find their dot products, scalar products. Okay, so negative 5p minus whatever this is, 42. So right, just take the components, multiply them together, and then sum them all up. Nothing crazy. That's 9 times 6, 54. Okay. The angle between A and C is equal to the angle between B and C. Find the value of P. Okay. So we know that this is also equal to this from the formula booklet. And then likewise, this one is equal to this one. And then because they have the same angle, then the angle between them is the same, so we can use theta. So what does this mean? What can we do with this? Okay, we can equate them because we know their thetas are 0, so or their thetas are the same, so we're gonna manipulate this to equate them. So this one is minus 5p minus 42 over length of A, length of C. So this is cosine theta. Likewise, this one here, cosine theta is equal to negative 8p minus 54 over length of B, length of C. Okay, so because these are both expressions for cosine theta and theta is the same, we can equate these two. So negative 5p minus 42 over length of A, length of C is equal to negative 8p minus 54 length of B, length of C. Now because they both have the length of C in the denominator, we can cancel those out. And then from here, right, length of A and length of B, you can find out what those are. Length of A is root, I don't know, 20, what's 25 plus 49? 60, 70, 74. And then 64 plus 81, it's like 145 maybe? Okay, and then, right, you can solve for P. Solve P. Use an equation solver. So, I'm gonna do just that. Okay, what do we got? We got negative 5p minus 42 over 74 is equal to negative 8p minus 54 over, what was it, like 145? Okay, equation solve. Yeah, that looks about right. What the hell? Approximate form, please. 4.79. Sure. Something like that. Oh, this looks like a HL binomial expansion. Okay, so this thing is q minus x squared to the power of negative 1/2 Okay. Let me pull out my formula sheet. Let's go to HL binomial theorem. I'm gonna copy this. Gonna paste it here. No? Sure, okay. So let's see. This is my A. This is my B. This is my N. Okay, coefficient for x to the power of 6 is 5,120. We will use that to find the value of q. Okay. So we are looking at the term in the expansion that would expand to x to the power of 6. So we're looking at this term right here, because if b is negative x to the power of 2, then, or no, oops, not this term, the one after this term. Because we essentially want the third term. 1, 2, 3, oh, the fourth term. We need to the power of 3. So that, you know, x to the power 2 to the power of 3 gives you x to the power of 6. So fourth term. Okay, so then that means that we have n minus 1 times n minus 1 times n minus 2 over 3 factorial negative x squared over q cubed, right? And then plug in n, which is negative 1/2. Okay, and then this is equal to 5120 x to the power 6. Okay, so that means that all of this stuff is 5120, and then we can use this to solve for q. Disgusting. Okay, what is this? This is negative 3 over 2. Negative 5 over 2. This is like 6. Sorry, I don't want to use the calculator unless I really have to. Okay, so we have negative, 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 and then another negative here. So positive 15 over 8 over 6q cubed is equal to 5120. Okay. So Q is the cube root of 15 over 48 over 5,120. Something like this? Sure. I'll go with it. Zero, 3, 9. And yeah, something like that. Okay, is this the last? Nope, there is 2 more short answer, and I'm a little under an hour. Uh-oh. Okay, these things are not lining up. Whatever. Okay, what is this? Question 8. A class of students plays tic-tac-toe amongst themselves. Each individual games between 2 people. Every student is to play every other student twice. However, Stefan left the class after he only played 7 games. All the other games not involving Stefan were played. By the end of the competition, a total of 513 games had been played. Determine the number of students that were originally in the class. Okay, so this is based off of a pretty famous problem, or not problem, but like, sure, let's just say problem, where if you have a bunch of people and everyone shakes everyone's hands once, then how many handshakes were made? So I already know that, and then so like this is like pretty approachable for me. So I don't think it would help if I just like spit out how it worked. So this is how I would approach it if I didn't know that, right? First off, you need to find a way to relate the number of handshakes or the number of games played for any amount of person. There's going to be a pattern between n people. We need to find a relationship between n people and the number of games played. And we'll keep it simple for now. Everyone plays everyone just once. We'll deal with the Stefan and the twice thing later. Okay, so what you should do is you should start with a small case and then build up and see if you can find a pattern. So for example, if we have 2 people, then that's pretty easy. You just play 1 game. If you have 3 people, then these 2 play with each other, and these 2 play with each other, and then these 2 play with each other. So then that means that you have 3 games played. If you have 4 people, then 1, 2, 3, 4, 5, 6. And then maybe this is enough to convince you of a pattern, but if it's not, let's just do 5 people as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So if we take a look at the pattern, we start with 1 when n is 2 people. It goes to 3 to 6 to 10. And then hopefully you guys can see that all you're doing is you're adding 2, 4, and then 5. And then the next one is probably like 6. Like this. So what that means is that this number 3 is literally the first term, 1 plus 2. 6 is the previous one, so 1 plus 2. Oh, oops, that's 3. My bad. This is a 3, 4. 3, 4, 5. Right, 6 is 1 plus 2 plus 3. 10 is 1 plus 2 plus 3 plus 4. Right, and then this makes sense because essentially, let's say that you have 4 people. The first person, he plays 3 games, right? Against each person. Then the second person only needs to play 2 more games with the other 2 people that he didn't play with, because the first person played with that person, right? So then that's 2. And then the last person that we haven't really accounted for needs to play with this person, right? And then that's all of the people have played with all of the people. So that makes sense. Therefore, we have this pattern, right? If you have 3 people, then the number of games you play is 1 plus 2. If you have 4 people, the number of games you play is 1 plus 2 plus 3. 5 people is 1 plus 2 plus 3 plus 4. So, right, that means that for n people, the number of games you play is literally just the sum of I starting at 1 to n minus 1. That's the shorthand, right? But like, right, if you have 9 people, then the amount of games you play is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, and then we stop at 8, n minus 1. Okay, so that's only if everyone plays everyone once, but in this situation, everyone's playing everyone twice, except for Stefan, who only played 7 games. So if we take away the 7 from the 513, which is what is this, 506? That means that this number is how many games would have been played if Stefan wasn't part of the group. So then this number is for n people, not including Stefan. So in other words, right, if we do 1 plus 2 plus 3 all the way to n minus 1, this should be, oops, not 506. This is with everyone playing each other twice. So then we divide that by 2. So 506 divided by 2. And then this is like 250 something, 258. So if all the people in the room minus Stefan played each other once, they would have played 258 games together, right? But they play each other twice, so that's 506, and then plus the 7 games that Stefan played. Okay, so from here we can find n. This is a, what is happening here? Stop. Okay, so how do you do this sum? If you don't know what n is, this is a arithmetic sum where this is your first term, this is your last term, And then your common difference is 1. Okay, and then just don't get confused. This is the sum of n minus 1 terms because there's n minus 1 terms, but then this is representing n people playing. Okay, and then this is pretty standard. We can follow the formula n minus 1, 2. I think it's 2 times the first term. Oh wait, no, we have the first and the last. Okay, easy peasy. 1 plus n minus 1. And cancel, cancel. Okay, and then we solve for n using whatever you would like. Let's use Desmos. So x minus 1 over 2. And then this should be equal to 258. So if I subtract 258, I get 2 answers. One's negative, one's positive. And then, oh, that's not a nice number. That should be a whole number, because that's n. Where did I mess up? $513 minus 7 games. It's 506 divided by 2. It's 253, not 258. Okay, 23 people, not including Stefan. So that means how many people are in the class? $24 with Stefan. What is this? Okay, get out of here. What? Stop. Uh-oh. Okay, hold on, I gotta abort. Okay, I'm just gonna delete. What is happening? Okay, this is question 9. We've reached the long answer. No, we haven't. Oh my god, okay. We have plane P. Constant height going this way. F6. Approaching this runway. Show that this angle is this one minus that one. Okay. Okay, easy enough to do. We have 2 right triangles. We have this one right here. That has this angle right here. So that means that tan of this angle, I don't know, I'll use like gamma or something, is x plus 2 over 6, opposite over adjacent, which means that gamma is the arctan of x plus 2 over 6. Likewise, we have this other right triangle right here. And then this one, call it whatever this symbol is. Actually, nah, let's use phi. Okay, for the same logic, right? Phi is the arctan of x over 6. And then, of course, our little sliver of an angle theta is the red angle minus the green angle, otherwise known as this. Nice. When the viewing angle, what's the viewing angle? Is theta the viewing angle? Yes. Is this radians? The rate it's changing is this. Find the speed of the airplane. Okay, so now we take this into related rates. We're gonna use part A. We're gonna implicit or differentiate it with respect to time. So then we have d theta over dt is equal to, and then we derive this part. You need to know arctan derivative, which is somewhere in here. Hello? This one, oh, you can't see it. 1 over 1 plus x squared. Beauty. So 1 over 1 plus x squared. Alright, if we do the chain rule, you don't use multiply by 1. Minus. Oh, well, okay, and then, well, times dx by dt. There is that chain rule part. Okay, minus 1 over 1 plus x squared dx dt. Okay. So we are trying to find the speed of the airplane, which is dx dt. So we can factor that out. So dx dt is going to be d theta dt. So this is how fast the angle is changing divided by this stuff. So I factored it out and then I divided it over. And then this is like pretty ugly. I'm gonna just leave it ugly. Because we're just going to be plugging in values for x and d theta dt. And then we just calculate dx dt. Okay, so what's d theta dt? D theta dt is 12.5 radians per hour. So this is d theta dt. I also need to plug in x. I do not currently have x. What I do have is I have the viewing angle theta. So we also will need to plug this into theta and then solve for x. So again, equation solver. So my radians is 1.78 is equal to arctan of x plus 2 over 6 minus arctan, I think it's x divided by 6. Okay, so x is 4.6, x is this distance, which I don't think can be negative, so 4.63. So this goes in here. and then we equation solve for x 4.63. Okay. Whoa. I think I need so 4.63 gets substituted for x in here and here, and then that should be your answer. Okay. Time to calculate. So 12.5 divided by bracket 1 divided by bracket 1 plus bracket 4.63. Oh, I think I need another bracket. Plus 2 bracket divide by 6 bracket squared bracket. Oh my god, how many brackets are there right now? Okay, I think that's enough brackets. Minus 1 divided by bracket 1 plus bracket 4.63 divided by 6 bracket squared bracket bracket. Please. Why did I get negative? Oh yeah, okay. That makes sense. Sure. Because as the plane is approaching the runway, the distance x is shrinking, so that's a negative. So I'm just gonna say that this is correct. And this is like 70 kilometers then, yeah? Yeah. If it's wrong, it's probably just because I plugged it in wrong or something. But that's the process. And then, oh yeah, I deleted the other questions. Am I on the long ones yet? Because I'm at an hour and 13. Okay, I think I'm in the long ones now. Okay, hold on, let me just print screen. Question 10. Okay, this is probably SL. Fiona, Lucy, blah blah blah. This is the thing. Find the value of V1. Okay, so you just plug in 1. Easy peasy. Find the time when the velocity is 5 meters per second. Okay, so I'm gonna use decimals. You can do all of this with your graphing display calculator. So first, I'm going to type in the function. So f of x, which is v of t in the question, is 8.14 x over square root x squared plus 0.2, where t is greater than 0, so I guess I can just specify where x is greater than or equal to 0. Okay, so here is your graph. We are gonna just plug in 1. So your graphing display calculator has a function, a calculator function where you can give it a function and then tell it to input a value for x. So 7.43. Meters per second. Okay. Find the time when Fiona's velocity is 5. So lots of ways you can do this. You can just make this equal to 5 and equation solve it. I can graph the value 5. And then I can find the intersection. So this x value is when Fiona's velocity is 5.348. Then we need to find the time that Fiona's acceleration is 4 meters per second squared. So acceleration is the derivative. So I'm going to do the same thing as this, except I need to graph or find the expression for the derivative, which is acceleration, and then solve it for when it's 4. Okay. Oh, yeah. I love doing quotient rule again. Okay, derivative of the top. Okay, times the bottom. Okay, derivative of the bottom. Half t squared plus 0.2 negative half. Okay, chain rule 2t, and then the top function. Oop. Square the bottom. Okay, so there's your acceleration. Find out when this is 4. 2 marks? Is there an easier way to do this? Okay. I have no idea. Okay. Oops. F. Okay, so this thing, right, you would graph it. Luckily Desmos, I can, if I define what f is, I can just tell it to graph the derivative. If not, you would graph this, right? Type this in. And then this is when acceleration is 4, so same thing. You're gonna graph 4. And then this is the time when Fiona's acceleration is 4. 5.9. Okay, write the limit of v as t approaches infinity. So you can see here that she eventually plateaus in her speed, which makes sense. What is that then, right? Because as x goes towards infinity, what is this number? We are going to factor out a t squared from the bottom. Too much blue. Let's change to red. And then t is positive, so when we factor out the t squared, right, this thing is going to become just positive t. these are going to cancel. This is going to go to 0 as t goes to infinity. So, 8.14 divided by 1 is 8.14. So meters per second. Right? And then you can see here at the y values, right? It's approaching 8.14. We can even graph it. And yeah, that's your limit. Okay, state the reason why this value in part CI is not valid in the context of the question. Okay, so this limit of her speed is for an infinite value of t, infinite time. This doesn't make any sense because she's doing a race. This race is only whatever, 200 meters on a racetrack. So this is not an applicable speed because this is the speed, or whoops, this speed, velocity is what she would achieve if she could run for an infinite amount of time and she had infinite stamina, right? So like she only has 200 meters to run, and obviously she's a human, so it's not like she has infinite stamina. I don't know, you just gotta say something like that. It's probably like 1 mark. Okay, and then we got Lucy, who has her own velocity. Fiona competes in the race and crosses the finishing line in front of Lucy because Fiona's faster. Find the distance Lucy is from the finishing line when Fiona completes 200 meters. Okay, so we need to find out how long it takes for Fiona to run 200 meters. Is there an easy way to do this? Okay, they're going straight, so they can't go backwards. Okay. Sure. Let's take the integral. So, just like how the acceleration is the derivative of the velocity, her position along the racetrack is the integral, definite integral of her velocity. So first, let's do Lucy's integral. Indefinite integral. And then this is looking like a u substitution. Right? U is t squared plus 0.2, so du is like 2t. Okay, and then that means that half of du is t, dt. So then this integral is going to become like 8.14 over 2 du over u to the 1/2, or root u. Okay, so let me clean this up. 4.7 integral of u to the negative 1/2 du. So 4.7 u to the positive 1/2 plus c with a 2. Oh, so then it goes back to 8.14. Sure. Yeah, okay. So then this is her position, indefinite, and then obviously when she starts the race, she should be at the beginning of the racetrack. So we know we can find C. So C is just 0. And then we need to find the time that she takes to complete the race. So then that means, right, S of t is equal to 200 meters. And then solve for u, or t. So yeah, 4.93 seconds. Is that realistic? To run 200 meters in 4.93 seconds? No, that's not possible, right? 200 meters is like... That's really fast. Did I integrate this wrong? Okay, let me do a gut check here. I mean, I think I did the integral right. Oh, I think I square rooted it. I was supposed to square. Okay, 200 divided by 814 minus 0.2, and then... Oh wait, hold on. Yeah. Silly me. Square. Then subtract off 0.2. And then square root. There you go, 24, that seems more reasonable. 24.6 seconds. Okay, and then if this, and then they obviously start the race at the same time, so then this is how long the other person runs for, Lucy. And then now we can find out the distance that she runs, because this is going to be from 0 till this time of her velocity. And then from there we can find out how many meters she is from the finish line. Oops. Okay, math. Fn integral 0 to 24.6. Okay, 8x divided by x squared plus 0.3 Oops. Bracket to the power of 0.5 dx. Please be something under 200. Yeah, okay. So she's 7.53 meters from the finish line. That seems good. That looks right. Okay, nice. Then let's do the next one. What is this? It looks like an entire essay. Question 11. Copy. Like, this is a whole page of just text. Okay. Hold on, let me check my phone. I've been getting a lot of messages. Amanda enters data from database. Okay, accuracy of any survey is independent. Previous records, 8% of her surveys are entered inaccurately. On a particular day, she enters 50. Find the probability that Amanda enters at most 6 surveys inaccurately. Okay, so this is a binomial distribution. Every survey has an 8% chance of being entered wrong. And then we have 50 surveys, so then that's a binomial distribution, the same trial over and over again, and they're all independent with the same probability of something happening. We want at most 6 surveys, so this is cumulative. So like, let's say X, right, X is number of wrong ones entered. Then we are finding the probability that she does at most 6 wrong. So 0, 1, 2, 3, 4, 5, 6. So this is a binomial cumulative distribution. So for TI-84, it's binom CDF. This is an upper boundary. TI-84s can only do upper boundary, if I remember that properly. So second vars distribution, binom CDF. We have 50 surveys. The probability of entering one wrong is 8%. We are interested in having at most 6. And then I don't remember if this is inclusive or not. Like, does this include 6? Let me Google this. Okay, TI-84 binom CDF inclusive. Yeah, it's inclusive. Okay. Okay, this is inclusive. Include 6. Paste. Enter. Boom. 898. Okay, given that at most 6 surveys were entered inaccurately, find the probability that exactly 4 were entered inaccurately. Okay, so then this is conditional probability. So we want to find the probability, and then this is the formula. Find the probability that she entered exactly 4 wrong, and then intersection with probability of her having less than 6, divided by the probability of her having less than or at most 6. Okay, so this is just a conditional formula, right? We have given that this. So then this is like p of x equals 4 given that x is less than or equal to 6. Okay. We know the denominator, that was part A. And then part B, this thing is kind of it's a silly statement because this is inside of this one. Because the probability of you being less than 4 and you being, the probability of you entering 4 wrong and at the same time being less than 6 is the same thing as this one. They do this a lot, right? Because like 1, 0, 2, 3, 4, 5, 6, right? This is less than 6. So this, right? So their intersection is literally the actual probability of being 4 itself. Okay, so then this is p of x equals 4 over p of x being less than or equal to 6. Okay, so then we need to find the probability of her entering exactly 4 wrong. Okay, and then we divide them. And then you should get this number, 0.227. Okay, and then if you're wondering what I did, because my calculator, the latest answer it had was the denominator, the less than at most 6. I take that and then I divide it by the probability of it being 4, and then I take the reciprocal of that so that I have it in the right way, where the top number is, yeah. But anyways, that's just me being lazy and whatever. So there. Okay, on a different day, Amanda enters N surveys. On this day, the probability that at most 6 surveys were entered inaccurately was approximately this. Find the value of N. Ew. Okay. So this is an equation solver. We are going to now pull out the actual formula for binomial probability distribution. Which is wait, SL, no, HL. Where is it? Yeah? Do they not include it? What? No, this is SL. The heck? Sure. Am I missing it? Am I going crazy? This is something you're supposed to know, right? The formula for binomial distribution? Like, you're supposed to have this formula, no? I swear, like this is a formula that you should have in your formula booklet, and you've learned this. Otherwise, I don't know how you could do this question. Okay, the probability of, you know, an exact amount of something happening follows this. This is an SL or HL formula, which is why I was very confused it wasn't in your HL section. But essentially, right, we need to find the probability of P0 plus, how's this only 3 marks? P1 plus all the way to P6. This needs to be 0.0367. How's this only 3 marks? Okay, I need room. Okay, I'll do down here. B. So we have N0, right? So that means that she has all of them correct. N1. How is this only 3 marks? Am I going crazy? Is there actually a better way to do this than what I'm doing right now? I'm trying to think, because this is only 3 marks. How... And then you would use an equation solver, obviously, to get this. But this takes like 5 minutes to type in. How is this only 3 marks? Is there a better way to do this? I mean, besides like guessing and checking, but oh my god. Okay, I'm gonna type this in and see. Okay, let me show you what I'm doing. So I'm doing an equation solver. Hopefully Wolfram Alpha can recognize the C notation. Okay, so that's 2. This one is 3. This is 4. This is 5. This one is 6. Copy this just in case. You've exceeded the maximum number of characters? Oh my god. Do I need this N? Because I might just skip this question. I don't want to type this into a TI-83. And it's only 3 marks. Let me just do like a quick guess. Okay, so at 50 surveys, that's like a 90% chance that she puts more than at most 6. So let's say she does 100 surveys. What is this? 303. Okay, so 100 is too many. 99. Not 99. 98. This is so stupid. 7. 6. 5. 4. There it is. I mean, yes, I could have like, instead of going down by 1 each time, I could have done more. It is pretty viable to do guess and check like this, although if you want to get full marks for a guess and check, you need to show, I think, 3. You need to show the actual one, and then you need to show the one after and the one before, so that like it shows the marker that you've been thorough in checking all of the trials. So you would need to show 95, 94, and then 93, just in case. Like that's how they did it for like other things, like how many years must you invest something, because then they need to show like, yeah. Anyways, okay, it's 94. I don't know. For 3 marks, I would guess it. Like, this is stupid. If you really wanted to do it exactly though, this is how you would solve for N. Stupid. Okay, then we got Bryce, Carmen. They have different errors. Okay, Amanda's 55, Bryce is 25, Carmen's 20. Find the probability that a randomly selected survey was entered inaccurately. Entered by Amanda. Given by, okay. So, first, each person can have a probability of entering the data. 55, 25, 20. And then once we've determined who has entered the data, then they have the chance of, you know, being inaccurate with their own errors or accurate. Was Carmen 11%? Yeah, okay. And then if we just want to find out what's the probability of data being entered inaccurately, then we need to add all 3 ways you could enter data inaccurately together. So that's 0.55 times 0.08 plus, so that's Amanda adding it inaccurately, plus Bryce adding this inaccurately, plus Carmen adding it inaccurately. And then I'll just write it here. This is gonna be something. Close my calculator again. Okay, 0.55 times 0.08 plus 0.25 times 0.06 plus 0.2 times 0.11. Okay, 8.1%. Right, this is the probability of being inaccurate. No, I'm almost at 2 hours, and I think there's one more question after this. Okay, entered by Amanda. Find the probability that is entered by Amanda, given that it was entered inaccurately. So find the probability that it was Amanda, given it was inaccurate. So another conditional. So this is the probability that it was Amanda and inaccurate over the probability that it was inaccurate. Okay, luckily we have those values and are calculatable. Okay, so this is it being inaccurate, so I'm gonna divide this by Amanda being inaccurate. And then take the reciprocal. Okay, so why is that? Why does it look like that? Oh, oops. No. Take this thing. Okay, forget it. I forgot a bracket. Let's do this. Okay, Amanda. Inaccurate. Divided by inaccurate. There you go. 54.3%. Okay. The following year, the accuracy of Amanda and Bryce works remains the same as did the percentages of all 3. However, Carmen's improved her accuracy. Now it's at X%. Find the probability that a randomly selected survey had been entered inaccurately was now, wait, what? The probability that a randomly selected survey had been entered inaccurately was now the same as the probability of that Carmen made the error when entering the survey. Find the value of X. Okay. Okay, so now Carmen has an error of X percentage. So that's 1 minus X, she did it correctly. The probability that a randomly selected survey had been entered inaccurately, so these three again, is now the same as the probability that Carmen made an error. So these three added together is equal to X, I think, if I'm interpreting that question correctly. So 0.55 times 0.8 plus 0.25 times 0.06 plus 0.2 times X is equal to X. And then we can solve for X. So 0.55 times 0.08 plus 0.25 times 0.06. So this is Amanda and Bryce. And then we're going to, this subtracts here, that's 0.8. So then we divide this by 0.8. So X is 0.737? 8, something like that. Okay. And oh, I got one more question. And then I think that's it, right? This is question 11. I'm copying question 12. Question 12 will probably take me 20 minutes. Oh, no. Okay, this looks like a integrating whatever factor question. Yeah. Okay. Okay, find this integral. This is going to be integration by parts. I forget the saying. If you have like parts, there's like an order of what you make like U and which one's dV. I think it's like Lippert or something. I'm gonna Google this. Oh, Lippet. Okay, it's an acronym. And it's the order of priority of which one you set as U. So L for log, I for inverse trig, P for polynomial, E for exponential, then whatever. So we have a polynomial and an exponential. So exponential takes priority over, wait, no, polynomial takes priority over whatever. So my polynomial is gonna be U. This is dV. Okay, so that means that du is 2x dx. dV is E x dx, so V is EX. Okay, so this is equal to U times V minus the integral of V times du. Okay, and then we repeat the process again. U dv. So du is 2 dx. V is ex. Why are they doing this to me at this late in the game? What am I even doing right now? E to the x. Sure. This thing. Let's I don't know if this is necessary. I'm gonna make it look nice. Here you go. There's your integrating factor, because you're gonna solve this differential equation. I forgot how this works. Okay, if we can get it to this form, okay, I'm gonna leave this on my other screen. Okay, so this is my dy dx. I'm gonna plus y equals x squared minus 5. Okay, so as you can see, my p of x is 1. This is my q of x. Okay, my integrating factor should be e to the 1 dx, which is just e to the x. So I multiply everything by my integrating factor. So this equation then becomes e to the x, I'm going to change this to y prime, plus e to the x y plus e to the x times x squared minus 5. Okay, and then what the integrating factor does is that this is essentially a product rule of whatchamacallit, e to the x times y, right? If we did a product rule with implicit differentiation, then it turns into this. So now we integrate both of these, because this is essentially this by dx, right? Like d dx. So ex times y dx equals 2 integral of this stuff. And then that's why they asked us to figure this out first. Okay, so then this means that ex to the y is equal to e to the x squared minus 2x minus 3 plus c, I believe. And then what are we doing? Oh yeah, we're solving this. Okay, and then you're done, right? Just cancel, cancel, e to negative x. Nice, there's y. Sketch the curve of a particular solution that passes through this point for negative 4 to 4, clearly labeling coordinates of any local maximum or minimum. Okay. Okay, let me write this without all the messiness. Okay, so then this represents a family of curves that when you take the derivative, it satisfies this differential equation. There's a family because there's a bunch of different curves. Each curve obviously has points, its own unique points that go through it. So we are interested in finding the exact curve that goes through this point. So we need to find out what c that is. So easy enough. This is x and y. We can plug them in. Figure out what c will be for these values of x and y. So 2, 9 plus 6 minus 3, c, e, 3, I think. Okay, what is this? 2, 12 plus c, e, 3, so negative 10 over E3. So here's our C value. Then we go to your graphing display calculator. We graph from negative 4 to 4, indicating maximums and minimums, which are all functions in your graphing display calculator. Okay. So here's my Desmos. Y equals to, what was it, x squared minus 2x minus 3 minus 10 over e to the power 3 times e to the power of negative x, right? Okay, and then we want this from negative 4 to 4. Okay, and then you use your graphing display calculator to find the value here, the maximum, the minimum, and the y value here. I don't know why it's not staying on the screen. Y equals 4. Y equals negative 4. Okay. This one, this one, this one. Oh wait, no, hold on. X, X. There. You know what? Here. There you go. Again, that's just me speeding it up. You can figure out all of these values and sketch it with a GDC. Okay, what else is there? Almost done, right? Consider the family of curves that are solutions. So we're back to this general equation. The tangent at x equals -3 is drawn for each of these curves. By considering the curve which passes through this point P and the curve which passes through this other point Q, and then these are going to be different values, show that all these tangents intersect at a common point and then state its coordinates. Cool. Cool. Okay, so here is the general equation, and then I added a slider for the C value because C can be anything. And basically that means that all of these different graphs are solutions. They're a family, right? And then I'm just keeping it between -4 and 4. These are all solutions to our differential equation. They all have a particular point at -3. Here. All of these points have a tangent line. And then they're saying that all the tangent lines intersect in one common point. So if you want to visualize it, that's what you would be doing. But I don't think we need to visualize to figure this out. This goes here, save some space. Okay. PQ. First, let's find the tangent slope. I think we'll find the tangent line. And then we equate the two tangent lines together to find the coordinate of their intersection. So, where is my stupid equation? So here, right, is our tangent gradient equation. Then we have 2 points that represent 2 different lines. -3p and I can't change colors right now. -3q. Okay, this one is going to have a slope of, I'll call it MP. 9 minus p minus 5. Then of course that means that MQ 9 minus p minus 5. Or sorry, Q. This means that the line that goes through point P is going to be y minus p is equal to 9 minus p minus 5 times x plus 3. This is slope point form. This is line Q. We got y minus q equal to 9 minus 5, 9 minus q minus 5 x by 3. Okay, and then these lines intersect somewhere, and then we need to find where. Am I missing something? All these tangents intersect at a common point. Okay, so then let's just equate the two. Line 1 equals line 2. That means that I will need to plus a p here, plus a q here, before I equate them. I don't know where I'm going with this, so we'll see what happens. Okay, solve for x, because I'm trying to find the coordinate where they intersect. That means I'm going to rearrange some terms. This term here is going to go over here. And then I'm going to subtract the p from the left side here. Okay, then I can factor out the x plus 3. And then subtract off this thing, so minus 9 plus q plus 5 q minus p. Okay, does this lead me anywhere? Nine, 5 q minus p. I think I'm heading somewhere. Q minus p are not the same value, right? Yeah, q minus p are not the same value. That means that this is not 0. So we can just divide, cancel these guys out. So x is -2, right? Cool. If x is -2, now we just need to find the coordinate of y. This is my only solution for these two generic lines, so they only intersect at this one common point. Then I need to find the y value. How do I find the y value? I can take any equation, right? That's what it says, any equation. So I'm gonna take this one. Okay, let's get y. plug into y equals x squared minus 2 minus 3 minus 10 over e 3 e to the negative x, right? Because that was one particular solution. I mean, I guess it didn't matter. You could have made c anything. You could have made c 0. Right? Sure, yeah. Okay, just plug it in. What do you get? Call this one g of x. Okay, g of, what was it, negative 2? 1.32? Is that it? This point, that's where they all go through. Okay, I'm gonna just do a little a little gut check. Ooh, that's not looking good. Okay, they all intersect here at this point. Should be 4. Oh yes, okay, I'm sorry. You cannot plug this into the function itself because that's the actual coordinate on the line. So do not do that. Sorry. Okay, now that x is 2, then what we do is now that we know x, we can slowly make our way and find y. Why can't I erase this? Oh, this is a screenshot. God damn it. Okay. I don't know what I'm doing. but I need to find y. I'm trying to do this algebraically. I mean, I know what the actual coordinate is right here because I used this. I mean, that's also, I guess, a valid way to do it, is to graph the derivatives. The tangent lines of two of them, and then just find their line of intersection at 4. I'm trying to do it algebraically. I don't know if I really want to at this point in time, because this video is like 2.5 hours long. But I feel like there's a way to do it algebraically. It's just currently this doesn't help me because I have 3 variables with 2 equations. So maybe the smarter way was to graph 2 tangent lines. No, wait, no, I have this particular x and y. Okay. Get this shit out of my face. Okay. Okay. -3, 2, y equals 2 equals what is the slope? 9 minus p minus 5. 9 minus 2 is 7, minus 5 is 2. So this is 2. X plus 3. There you go. Okay, we use this one, right? Because we know this. Bam. And this goes in here. This ends up being 4. Okay. Whew. Overall, I think this was a I would say that this is a little bit more difficult than a usual paper 2 would be. Yeah. And then there you go. I don't have paper 3 again, but if you heard me talk at the beginning of the paper 1 video, it was easier in different ways, in 2 different ways. They gave you more time and the question itself was easier. So I don't know. Hopefully you guys did well on that one. Thank you for watching and seeing me struggle. And yeah, I don't know. This might be it. I have the SL papers I guess I'll go through, and I don't know about the next year. My source is gone. I had a source. They also quit this year, at the end of this year. So I have no more ties to my source in IB. So we'll see. Okay, thanks for watching.